the IM351 Extra Practice number 7 solutions on solving polynomials by factoring. There's a puzzle that goes with this. Let's go ahead and check that out. So here's the puzzle that goes with that extra practice. In this one, we're trying to solve the riddle, what happened when Zonk blew air into a rubber glove? And there's this nice little graphic they've given us to show us what they're talking about. So the idea here is we need to solve each of these equations, and wherever we see the solution to the equation we just solved, we have to put the letter that goes with that equation above the solution in one of these boxes down below. So let's go ahead and give this a shot. All right, let's kick things off with problem number G. It's the first G. This is basically problem number 1. In this one, we're trying to solve this polynomial. So one thing I'm always looking for right away is common factors, and I see that we have an n in each of these terms. So I can factor an n out of all that. That leaves me with n squared plus 8n plus 12. I can bring down that n, and then for the rest of this, since I just have a 1 next to the n squared inside the parentheses, I can just look for factors of 12 that add up to 8. So we got 1 and 12, that doesn't work. 2 and 6 works if they're both positive. So I can write n plus 2 and n plus 6. Now setting each of these equal to 0 and solving, if n equals 0, then, well, n equals 0. And then if n plus 2 equals 0, then we have n equals negative 2, and then we have negative 6 zeroing out this last parentheses. So 0, negative 2, negative 6, I see those three things right here, so we're going to put a G right there. For this next problem, which is the first of 2 A's on this one, I notice that we can again take out some common factors. We have an m that can come out of both of these terms. That leaves me with m squared minus 16. So let me bring down that m. And then for the stuff inside here, I notice I've got the difference of 2 squares. This is an a squared minus b squared kind of situation, so I can use this shortcut here, where I basically square root both things and put a plus and a minus in the parentheses with them. So the square root of m squared is going to be m. Square root of 16 is 4. We have m plus 4 and m minus 4. Zeroing each of those things out, we have m equals 0, negative 4 for that second parentheses, and positive 4 for the third one. So 0, positive, negative 4, I see all those right here, so that's an A. For this next problem, I notice that we're not in standard form, so let me move everything over to one side so I can have 0 on the other, and factoring would actually help me at that point. I'm going to move everything over to the right side so that I can keep this cubed term positive. I like my highest exponent term to be positive, so I'm going to have 5t cubed minus 19 squared minus 2t. And now since I can't take out any common factors, well actually I can. I can take a t out of this. So that leaves me with 5t squared minus 9t minus 2. I can't really do anything else for this 5 here, though. I can't factor out anything to get rid of that. So I'm going to go ahead and use the AC method on the stuff inside there. 5 times negative 2 gives me an AC value of negative 10. So I'm looking for factors of negative 10 that add up to negative 9. That would be 1 and negative 10. So splitting this up, I'm going to have everything is going to be the same, but I'm splitting up negative 9t into a plus 1t minus 10t. And now let me go ahead and use grouping since I have four terms on this stuff inside the parentheses. So we've got the t that we brought down in the beginning. We can take a t out of 5t squared and t. That leaves me with 5t plus 1. For the next two terms, I can take out a negative 2. That leaves me with 5t plus 1. I took out that t in the beginning. It's still there. This 5t plus 1 can come out now. And then t minus 2 gives me the last factor. So setting all those equal to 0 and solving, we have t equals 0 for that t out there. For this middle one, if I subtract 1 and divide by 5, I've got negative 1/5. And then finally, t equals 2 for this last parentheses. So 0, negative 1/5, and 2, that's the very first option over here. So that's getting an H. D, at least the first D out of the batch. This one, it looks like it's not in standard form, so let's subtract 10a to get it over to the left side. So now we've got all that zeroed out. And taking a look at all my terms here, I notice they all have an a. So let me factor an a out of all that. So that leaves me with a squared plus 3a minus 10a. And I can bring that a down, and the rest of this, it looks like I could just use regular factoring. So factors of negative 10 that add up to 3. So that would be negative 2 and positive 5. So I've got a minus 2 and a plus 5. And then setting each of these equal to 0 and solving, we have a equals 0, positive 2, 2 minus 2 is 0, and then negative 5. Looking for those answers, let's see here. We've got 0, negative 2. That's not what I need. Let's see, 0, 2, negative 5 there at the very end. So that's a D right there. Next up, we have problem G, the second problem G out of our list. This one is also not in standard form, so let's subtract that 24k to get it over to the left. And at this point, these all have a k that they can contribute, so I'll take out a k for sure. And it looks like these are all also divisible by 3. That's about as good as I can do on common factors. So 3k coming out of everything. That leaves me with 10k, or actually this first term here, 3k squared is my first term. And then this next one is going to be 10k. I was already thinking too far ahead there. And then finally, 24k divided by 3k is going to give us minus 8. Looking inside, there's no shortcuts I can use to factor this 3k squared business. But I can use the AC method. So let me get my AC value. 3 times negative 8 gives me negative 24. So I'm looking for factors of negative 24 that add up to 10. So let's see, we got 1 and 24, that doesn't work. 2 and 12 I think would work if I did negative 2 and positive 12. So we'll split this up into negative 2k plus 12k for that middle term. So using some grouping, since I've got 4 terms in there now, I've got this 3k that I took out in the beginning. I don't want to lose that. But in here now, these first 2 terms, I can take a k out of those, leaving me with 3k minus 2. And for my last 2 terms, I can take out, let's see, these are both multiples of 4. I can take out a 4 from those. That leaves me with 3k minus 2. So I've got the 3k that I took out in the very beginning. Then I have this 3k minus 2 common factor coming out. And then, last but not least, we got the k plus 4 going in its own parentheses. Now I can set each of these factors equal to 0 and solve. If 3k equals 0, then k equals 0. That's one of them. 3k minus 2 equals 0. If I add 2 and divide by 3, I've got 2/3 for my next value. And then negative 4 will zero out this last parentheses. So we have 0, 2/3, negative 4. That's all right here. So that's going to be a G right there. For this problem, the only problem I on this problem set, this one is not in standard form. So I'm going to move everything over to the left side just to keep this u cubed positive. So I'll have u cubed minus 14u squared minus 32u equals 0. Next, I can take a u out of all of these. That leaves me with u squared minus 14u minus 32. And now on the inside, I just need factors of negative 32 that add up to negative 14. So we got 1 and 32, that won't work. 2 and 16 works if I do positive 2, negative 16. So I've got u plus 2 and u minus 16. Setting each of these equal to 0, we end up with u equals 0, negative 2, and positive 16. And all of those things are right here, this one, so this is going to be an I. On this next one, problem T, this is an example of quadratic form. We've got x to the 4th, x squared, constant. So I can treat this like a quadratic and just use x squared instead of x when I factor it. So looking to factor this, I need factors of 36 that add up to negative 13. So 1 and 36, 2 and 18, that's not working. 3 and 12 is a little bit better, but still no good. 4 and 9, those add up to negative 13 if they're both negative. So I'll have x squared minus 4 and x squared minus 9. Now I'm going to set each of these factors equal to 0 and solve. I could factor them further, but it'll be faster just to solve by square rooting. So this first one, I can say x squared equals 4. Square rooting both sides, I have x equals plus or minus 2. Have to remember to throw in that plus or minus. And then over on this branch, we've got x squared equals 9. Square rooting both sides for that one, that's going to be x equals plus or minus 3. So let me see here, positive, negative, 2, and 3. All of those 4 answers are right here under this option, so I'll put a T right there. Problem E, we have something that's not quite in standard form. So let's begin by getting this 7d squared over to the left side. I'm going to do that by subtracting it, and I'll put it between the d cubed and the d. So we have 2d cubed minus 7d squared plus 6d equals 0. And at this point, it looks like there's no common factors I can take out except for a d, so that's at least something. That'll leave me with a 2d squared minus 7d plus 6. And the stuff inside can't really be factored with common factors or any other technique, aside from using the AC method or guess and check. So let me go AC on this one. We have 2 times 6, giving us 12 for the AC. So I need factors of 12 that add up to negative 7. 1 and 12, 2 and 6 doesn't work. 3 and 4 works if they're both negative. So let me split this up into a negative 3d minus 4d. And now I've got 4 terms inside there, so I can take out 2 from each pair for part of my grouping process. So we have a d that we took out initially, a d coming out of the first 2. That leaves us with a 2d minus 3. And then for the next 2, I can take out a negative 2, leaving me with 2d minus 3. So there's the d I took out in the beginning. There's the 2d minus 3 that I can now take out because it's a common factor. And finally, there's the d minus 2 leftovers as the last factor in this bunch. Setting each of these equal to 0 and solving, I've got d equals 0 for that first d there. And then for this next one, I can add 3 and divide by 2 to get 3 halves. And then I get 2 for my last answer because 2 minus 2 is 0. Looking for all those answers down below here, I see 0, 3 over 2, and 2 right here toward the beginning. So we have an E going there. Here we go now with problem H, number 2, the second H on there. This one is, like many of the others, not in standard form. Let's begin by adding this 6v cubed over to the left side to get everything on one side. So now that I've got this set up, it doesn't look like I can take out any common factors for the coefficients, but I can take a v out of everything. That'll at least help a little bit. So that's 6v squared plus 17v plus 5. For the stuff inside, I'm going to use the AC method to untangle this. So 6 times 5 is 30. And now I need factors of 30 that add up to 17. 1 and 30 doesn't work, but 2 and 15 does. Positive 2, positive 15. So I'm going to split this up into 2v plus 15v. And I'm going to use grouping on the stuff inside. So I've got the v that I took out in the beginning. And then for these first 2 terms in here, I can take out a 2v, leaving me with 3v plus 1. For the last terms, 15 and 5, I can take a 5 out of those. That leaves me with 3v plus 1. So putting it all together, I've got the v that I took out initially, the 3v plus 1 common factor that I can now take out, and the 2v plus 5 leftovers. Setting each of those equal to 0 and solving, I have v equals 0. And for this next one, if I subtract 1 and divide by 3, that's negative 1/3. And then finally, subtract 5, divide by 2 for negative 5 halves. And all of that stuff, let's see, where is it? We got negative 1/3, negative 5 halves, 0. It looks like it's right here, so we have an H going there. For problem O, the only letter of its kind, we have something in quadratic form. So I can treat it like a quadratic and just use x squared instead of x to factor it. So for factoring, I need factors of 9 that add up to negative 10. That's not so bad. How about 1, 9, if I make them both negative? So I'm going to write x squared minus 1 times x squared minus 9. Setting each of these equal to 0 and solving, I can write x squared equals 1. And then square rooting both sides, I get plus and minus 1 for that. And then I have x squared equals 9. Square rooting gives me plus or minus 3 for that one. So we've got 1 and 3, -1, -3. That's all right here between the g and the t, so put an O in there. And that might be the word got, but we have to keep going and solve all the problems before we're really sure about anything. For problem B, I'm going to start by putting this one in standard form. I'm going to subtract everything over to the left side. So I have 5w cubed minus 40w squared plus 80w. And it looks like I can take both a 5 and a w out of all that. Leaves me with w squared minus, this is going to be, let's see, 8w plus 80 divided by 5, what is that, 16? So I've got the 5w I took out in the beginning. The stuff inside here actually is a perfect square sandwich. So I think I can use my a squared minus 2ab plus b squared shortcut, where I basically just square root the two things in a squared parentheses. So square root of w squared is w. Square root of 16 is 4. And since my middle term is negative, I'll make this a -4. Everything squared. If I multiply w and -4 together and double it, I do get -8w, so that does check out. Now, setting each of these factors equal to 0 and solving, if 5w equals 0, dividing by 5 gives me w equals 0. And then for the stuff inside here, 4 minus 4 is 0. And the fact that it's squared doesn't really matter. It just means we have like a double root of 4, but it's still just 4 in terms of different answers. So looking for that down below, I see 0 and just 4 right here. So that's where I'm going to put my b. And that looks like the word big, but again, we don't really know until we do the rest of these problems. Next up, we've got problem A, the second A in our problem set. So for this one, just like before, let me get this in standard form. I'm going to subtract 2y to do that. And now for common factors, I can take out a 2 and a y. That leaves me with 4y squared minus 1. The 2y can keep coming down. The 4y squared minus 1, this is really a difference of squares, a squared minus b squared situation. So square rooting some things, I've got the square root of 4y squared, which is 2y. Square root of 1 is 1, so that's 2y plus 1, 2y minus 1. Setting them equal to 0 and solving, if 2y is 0, then y is 0. 2y plus 1 equals 0, we can subtract the 1 and divide by 2, that's -1/2. And then for this next one, we just add the 1 and divide by 2 to get +1/2. So 0, negative and +1/2. I see that over here toward the end, so there's an A. And we're finally on to the last problem. It's an N. That's what we'll be putting somewhere. So let's see here. Everything's in standard form. That's a good way to start this. I can take out a common factor. These are all even numbers, so at the very least I can take out a 2. They also all have a q, so let me take out 2q. That leaves me with 15q squared. This is going to be a 7q, and then minus 2. I can't really do any shortcuts on the stuff inside, so I have to use my AC method. 15 times -2 is -30, so I want factors of -30 that add up to 7. So 1 and 30 doesn't work, 2 and 15 doesn't work, 3 and 10, I should be able to get something to work with that. I have -3 and +10. So I'm going to split up this 7q into a -3q plus 10q. Now that I've got 4 terms inside, I can use grouping. So let me take down that 2q again, just so I don't lose it. And then the first 2 terms in here, I can take out a 3q, leaves me with 5q minus 1. And then for the last 2 terms, I'll take out a 2, leaving me again with 5q minus 1. So I've got the 2q I took out before. Now I have a common factor of 5q minus 1 that's coming out. And finally, 3q plus 2 going into that leftovers parentheses. Setting each of these equal to 0 and solving, if 2q is 0, then q is also 0. 5q minus 1 equals 0. We can add the 1, divide by 5, so that's 1 over 5. And then for this last parentheses, we can subtract the 2 and divide by 3. That's minus 2/3. And all of that stuff is actually here. That's the last blank toward the end here. So we get an n in there. And that was the last problem, so I think I can go and solve the puzzle now. All right, we've done all the math questions. Now it's just a matter of seeing what this says. So what happened when Zonk blew air into a rubber glove? He got a big hand. Oh, I see. Because he's like a performer, so you give someone a big hand if they're performing well. But, I mean, if you blow air into a rubber glove, it becomes a big hand. Very funny. A joke worthy of Zonk, I'm sure. Till next time, Mr. Sutton signing off.